Hello and welcome to another video. In this video we're going to be working on a relative sort array, and in this one you have two arrays and the elements of the second array are distinct, and you want to sort the first array based on the layout of the second array. So this is the sort order you want for elements in the first array, and then everything that doesn't appear in here you want to put at the end in increasing order. So here's the first example, and so the elements that don't appear in this array are 7 and 19, so you just put them in the end in decreasing order. And everything else should be in the same order. So 2, then 1, then 4, then so on. And there can be duplicates. And then the second example. So how do you do this? And there's kind of a few ways. So what we're going to do, is we're going to get a hash map for array 1. And we're just going to get a count of all of these elements. So let's just go through that. So let's just say 1 has a count of 1 looks like. 2 has a count of 3. 3 has a count of 2, 4 has a count of 1, 6 has a count of 1, 7 has a count of 1, 9 has a count of 1, and 19 has a count of 1. And the hash map is better because we can just go through and the array 2 now and just check okay, for all these elements, do they exist and how many are there? And if they are there, then we're going to put them in our output array. So let's do that and see what we can do with the result. So we're going to go through array 2 now, and we're going to say okay, is 2 in our hash map? Yes, it is. There's 3 of them. So let's put in 3 2s. Okay. And when we put in the thing, we'll get rid of it, and I'll show you why for later. So we got rid of that guy. Now we put in 1, or we put in 2. Now we check, is there a 1? Yes, there is. So 1, 1. Now, is there a 4? Yes, there is. There's 1. So 4. Is there a 3? Yes, there is. There's 2. Is there a 9? Yes, there is 1. And is there 6? Yes. So then the numbers we have left that aren't in array 2 are 19 and 7. So basically all this rest of the stuff will get out of the hash map, so we'll have these 2. Then we can just walk through our array again, or our hash map, either one. So we can walk through our keys or our array and get the rest of the elements and put those in a new array, because there might be a lot here. So our elements will be 7 and 19. And then we can just sort this guy. And then once we sort this new array of elements that aren't in array 2, because these are all counts that we have left over that aren't in array 2, then we can sort it and put it over here. And then we'll be done. So that's basically the idea. Get a count for every number in array 2. Check its count. If it is in the counts, put them in. Get rid of the counts. And then for everything left over, in array 1, you can just traverse either array 1 again or this guy, whichever one you want. If the element is in the counts, that means it wasn't in array 2 because we already traversed through array 2. So then we just put it in here. So let's take a look at the code. It's kind of long, so I just didn't want to code it in a video, but I'll explain. It's pretty easy. So you have an array of counts. Go through all the numbers in array 1 and update the count. Then you make a result array, which is the length of your array 1. And you make an index in your result array where to write things in. Go through all the numbers in array 2. If that number exists in our counter, get the count and loop, and however many times it exists, put that in the result. Then afterwards remove it from our hash map. So then our hash map will only hold numbers that aren't in array 2. Then we make an array. So you can use an array or a list of extra. Either one's fine. And we just go through array 1 again and we check if it's still in our hash map. That means it wasn't in array 2, so it's extra stuff. We add it in, we sort our extra array, and then for every number in the extra array, we just add it to the result because it's already sorted. So just a bunch of steps here. I think it's maybe harder than an easier problem, not too hard, to figure out what to do, maybe an easier medium. Okay, and there we go. So you can use an array, you can use an array list. An array just becomes trickier because you have to have the indices match exactly. Array list is easier, and in other languages, obviously, you can have a vector or a Python list, which are easier than an array. Yeah, so this is going to be, let's figure out what we're doing. So we go through every number in array 1, that's O of n. So let's say this is n, and let's say this is m maybe or something. So this is O of n. Then we go through every number in array 2, so that's O of m. And then we loop through this guy, and so this can have up to O of n. So this is n plus m. And then we go through array 1 again, so that's O of n, and then we sort everything that's not in array 2. So worst case, let's say worst case, the whole of array 1 isn't in array 2, and then we're going to have to sort array 1. So I think it's going to be something like, so we have to sort array 1, which is n log n, worst case. Like imagine there is no array 2, or none of the numbers in array 1 are in there. And we also have to walk through array 2. So I think it's like this is the time. And space, so we make a hash map for all the items in array 1, so that's O of n. Imagine they're all unique. And then we have result, which we don't count, and then we have the extra. And the extra is also worst case scenario O of n, if they're all unique. So I think it's just O of n. We don't really store anything from array 2, we just use elements from array 1. You can use other things here. You can use like a counting sort or some other thing. This is just like another way of doing it. And I showed the counting sort yesterday. So hopefully this one makes sense. And if it's helpful, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.